Hello, Chemistry 1A. In this recording, I will be walking through the procedure for conducting one of the trials in the Hess's law experiment, specifically the sodium hydroxide and hydrochloric acid portion of the experiment. As is always the case, first thing is about safety. Make certain we've got our safety glasses on. The two chemicals that I will be using in this one include sodium hydroxide and hydrochloric acid. You see, of course, that they're both 2 molar, which makes them reasonably concentrated solutions. If you get them on your skin, the proper response is to just go wash them off promptly. They will not burn you immediately, but you definitely don't want to leave them on your skin or on any paper or anything that you happen to spill it on, because it will cause a stain or other problem. The other thing that I'd like to point out about safety, excuse me, where did it go? Ah, yes, this one. You have styrofoam cups that were given to you in the kit, and note that mine, or at least one of mine, had a hole in it. I think you can understand how, of course, that would be a problem, so please do take a quick look at them to make certain that they are intact. And along that same line, we have the thermometer that we're going to use, and you can see, of course, that's fairly pointed. And since this already has a hole in it, I think you can see it's pretty easy to punch a hole in those. And if you do that while you've got the materials in them, then of course you'll have a big leak. So please be cautious about that. Also, please make certain you give yourself enough room to work so that you're not in a cramped space where you might accidentally spill things. The other thing I want to show you is a look at how I might have prepared a lab book prior to beginning this experiment. I will be posting those PDFs, but as you should be looking at this video before you conduct the experiment, I thought I'd just hang them up here for you to take a look at. So again, you can see I've got a title, the reactions. Note number 2 and 3 are the other 2 portions of this experiment, and I haven't put those in there. You should have a list of the reagents and chemicals and their concentration. The procedure, you do not need to write the procedure at all. You simply provide a proper literature reference to the URL for the HOL website, and that is all you need to do. If you were doing a truly novel experiment for yourself in a research type setting, you would need to write out that procedure in as much detail as is necessary. There's not a whole lot to put in here in the way of diagrams, but the 2 little containers show sodium hydroxide and then getting added together for HCl. And then note that I'm getting the lab book prepared to enter the data that I know I'm going to collect. That is to say, the initial temperature of the HCl and the initial temperature of the sodium hydroxide, and of course the calculated average. More on those later. In addition, I have prepared a table to put the data in that I will be needing. Now, as I've said before, right, I'm not looking for neatness of handwriting, right? We all know that my handwriting is not real good, but there's nothing preventing you from drawing straight lines with the use of a ruler or some such thing. So that's an approximation of what your data table should look like before you begin the experiment. The experiment also calls for you to put various data and upload PDFs. I'm not going to walk through all of that. You can read that as you conduct the procedure as well. Also, before I begin the experiment, I want to point out something about why we're collecting 5 minutes worth of data. So let me turn on my thermometer, and you can see, let me get that position. There we go. 20.4 degrees Celsius, right? My house is a little bit cool at the moment, but 20.4 degrees Celsius. Now, it is also the case that human body temperature, unless the person has a fever, is about 37 degrees centigrade. So I'm going to hold that right there. Let me see if I can get it all. I can't get it all in, so I'm going to have to hold it back a little bit. I think you can still read the temperature. And here's my hand. My hand's at about 37 degrees Celsius, or at least inside of my hand is. And so I'm going to wrap that on there, and I'm going to grab on in 3. 1, 2, 3. Well, why isn't it at 37 degrees C? Oops, there it goes. So we see that there is a time lag between when the thermometer records the temperature and when it's exposed to that environment. In other words, the thermometer is exposed to the 37 degrees centigrade environment, but it's taking time to react. The same thing is going to be true later when we put this into a solution that has just reacted and heated up. So for that reason, we're collecting 5 minutes worth of data, and I will demonstrate how we evaluate that data at a later time. So again, the point being, there is a time lag between when the thermometer is exposed to a solution and when it properly records that temperature. Again, more on that later. Okay, let's begin the experiment. Safety glasses on, of course. We have, of course, the 25 mil graduated cylinder. And the procedure calls for 10 milliliters of sodium hydroxide. And it is important that it be as close to 10 milliliters as you can manage. In previous situations, I've said that it really doesn't make much difference. This one, it says 10 milliliters exactly, so we'll get 10 milliliters as best we can. So this one has a small hole. It's going to take a little bit of time to squeeze out 10 milliliters. I'm in no big hurry, so I'll just keep going and going. By the way, there's not much in the way of excess chemicals, so you really only get one shot at most of these. So if you make a mistake, you may not have enough to repeat it. So let's just kind of keep that in mind. Now I'm getting real close to my 10 milliliters. So I'm going to hold that up, make certain that the meniscus is right there at 10. Okay. Okay, so that's at 10 milliliters. I'm going to pour this into one of them. Now, I'm going to use my, the procedure calls for distilled water. I'm using, just purified water that we've talked about before. And I'm going to go to my sink and rinse this out. And, here I am, I'm back. The nice thing about these plastic graduated cylinders and glassware is they hold on to very little water. So I might, if I looked real hard, might find a drop or two of water. Ideally, there would be none, but in this circumstance, what tiny little bit remains is going to be acceptable. So I'm going to set that aside. I'm going to get another one that doesn't have a hole in it. And should have done this before, but I guess I can do it now. I'm going to label these as to which is which. That one is my sodium hydroxide. Label this one. This is the hydrochloric acid. Always good to label chemicals so that we know what they are at a later time. After all, they are clear colorless solutions, all of them. With no odors, it would be otherwise very difficult to tell them apart. Okay, so here we go again. I need 10 milliliters of the HCl. And again, don't try to rush this. If you squeeze real hard on the container, you're just going to wear yourself out a little bit. It'll get there all in due time. Again, you can see I'm getting my eye level right to where the 10 is. so that we eliminate what is referred to as parallax error. And remember, it's always easy to put another drop in. If you go too far, it's exceptionally difficult to take a drop out. So the HCl goes in there. Now, right now, well, I know that it's dirty. I'm going to rinse it out. Okay. Set that aside. It will not be needed until the next trial. Now, this is a experiment, of course, in thermochemistry and thermodynamics, and we know that it's all about heat. So we need to know the temperature of the solution initially, right? We've talked about T sub F minus T sub I a number of times. We need to know the initial temperature. But the problem is we can't measure the initial temperature of the reaction because as soon as the reaction is mixed, it reacts. So we're going to measure each of these separately. And now I can't show you this because it's, I mean, you can look at it. I don't know if you can read that. I think it's 20.1. Give this a couple of minutes. No, I shouldn't take my safety glasses off, but I can't read with them. So this reads 20.0 degrees. Now, I'm going to write that down here in a moment. You can see I'm going through my notebook. I'll write down 20.0 for the sodium hydroxide. Now I'm going to go over to the sink and rinse that out. Give that a quick rinse. Okay, so I've got that rinsed off. Got my paper towel. Dry that off. Going to come over to the HCl, which should be at the exact same temperature. They've been sitting out in my house now for a while. So there's no reason to think that they're going to be at different temperatures. And you can see the thermometer moving a little bit. When I rinsed it off with the water, it cooled it down. And this is adjusting. I'll let you look at it. You can kind of see it moving. And the question is, well, when do you stop? Well, it won't take long at all, and the temperature will stop moving. This one's still adjusting. And again, I'm just barely letting this rest there. If you push on it again, you'll push a hole in the styrofoam cup and of course lead to a mess pretty quickly. Okay. So this says, I'm going to call that good. I see. No, it's still moving a little bit. It's still moving. And the other thing you'll notice is there's only 10 milliliters in here. There's only perhaps that much of the tip of the thermocouple. This is a thermocouple that's actually in the solution. Okay, 19.6, we're going to call that good. I'm going to, again, give this a quick rinse. Okay. Now, at this point, I'm going to set my thermometer down off screen. You can't see it. You need to have a timer because you're going to be collecting temperature at 15-second intervals. So I'm using my phone. I suspect most of you as well. And I'm going, of course, to the stopwatch function. And it's a little bit challenging here. Don't worry if you're off by a few seconds. It simply will not make a difference. But you do want to get everything positioned because when I mix these two, I'm going to set those down and start the timer. Don't do this so fast that you end up spilling something. The quality of the data will be just fine, even if you do wait a few seconds between mixing and pushing the start button. So again, I'm getting everything set. I'm going to mix these two together. put the thermometer in there, and then a little bit off screen, I'm going to push the start button, and I'm going to record the time as soon as I put it in there, as soon as I push it, and then at every 15-second intervals thereafter. So I believe I'm all set to push start. I have my pen ready. And again, the key here is you really have to have everything ready because you don't have enough chemicals to do this over. And if you're not completely ready, the reaction's over, you've lost your opportunity to get your data. So I got pen, timer, thermometer, solutions, temperature. Here we go on 3. Pour that in there. There will be a drop or two that doesn't quite make it in. I put that in there. I push start. It's hitting start. I got 22.3 degrees. Coming up on, and let the timer roll. Don't start it. I've got, and you can look at the timer as I do. I got 15 seconds. I got 30.3 degrees. And I'm going to give this just a little swirl. Coming up on 30 seconds. 30 seconds, 31.7 degrees. Write that down. And at this point, there really is no reason to continue to stir. Acids and bases react very quickly. Pardon me, I got to stop talking because I'm coming up on 45 seconds, 32.1 degrees. All right, there's no reason to stir this. The acid-base reaction mixes quickly. It's over effective immediately. So now as we're doing is measuring temperature. I'm at 60 seconds. I got 31.9 degrees. Now there's not much to do except for wait the additional 4 minutes, and I'm just going to call out the numbers as I get them. 31.6 degrees. The, oh, pardon me, let me get this number coming up. 31.3 degrees. The styrofoam cups are our coffee cup calorimeter. They absorb very little heat, and as for our purposes, we're going to assume that the amount that they absorb is 0, 31.1. That is not strictly speaking true, but under these circumstances, it's a reasonable assumption that will not prevent us from getting the reasonable results. Coming up on 2 minutes. And I have 30.9 degrees. And of course, the temperature is coming down. The temperature is coming down is because the room that I'm in is at about 20 degrees C. And of course, the solution is warmer than that. Coming up at 215, 30.8 degrees. And so just like anything that is any warm solution in a cool environment, the temperature is going to drop, which is what we're seeing. Coming up on my next measurement, 30.8 degrees. .245, still, oops, temperature went up, 30.9 degrees. Of course, the temperature didn't really go up. The temperature, the recording of it, right? We haven't talked a lot about error analysis, but there's going to be fluctuations in error. That's all part of significant figures. 3 minutes, 30.8 degrees. So we're at 3 minutes. We continue this for 5 full minutes, coming up at 3:15 right now, and I see 30.5 degrees. Coming up on 3:30 right about now, and I have 30.2 degrees. 3:45, I have 30.0 degrees. Coming up 4 minutes, I have 29.7 degrees. 4 minutes and 15 seconds coming up right now. I have 29.5 degrees. Coming up on 4:30, I have 29.3 degrees. And just 2 more measurements coming up. 4 minutes and 45 seconds right now, 29.2 degrees. And the last measurement at 5 minutes, coming up in just a moment. Right now, and I have 29.1 degrees. Okay. So again, I'm done. I can stop my timer. And again, rinse this off. Now, ideally, this would be nothing more than sodium chloride and water. But if I was not perfect in terms of the amount of solutions that I added, or more likely if the solutions were not perfectly 2 molar, which they may have been close, but they were not perfect, there may be a small amount of residual acid or base left in here, making this ever so slightly acidic or basic. But practically speaking, it's pretty close to neutral. So I'm going to take this out. I'm going to dump all that out. Rinse that out with tap water a couple times. Set these aside. You will need them again. So for this experiment, and I don't know if we need them for a subsequent experiment, but certainly don't throw them away yet. Okay, that is the summary of the experiment. Follow the procedure exactly. I've got some calculations to do, but I'm pretty certain that these results are precisely what we would expect, and we'll be able to get some very good calculations and evaluations of the enthalpy of the reaction, which happens to be a neutralization reaction. All right, so I mean, by the way, there's my data table for the data that I collected. Actually, one other thing I wanted to point out real quickly, because I made a mistake when I was doing my, it's over here, right? When you make a mistake, not if you make a mistake, because you're going to make them in preparing your lab book, the proper thing to do is cross them out. You should never use whiteout pencil or make erasures in a lab book. Everything that you do should be visibly there for others. I will be preparing another video that shows the calculations for this trial of sodium hydroxide, as well as walk you through a little bit of the calculations for the other reactions that we're doing. I'm not going to do those completely for you, take all the fun out of it for you, but I will touch on those a little bit. Very good. Have a wonderful day.